Hello.
Hello, it's finally nice to meet you. I know we've been communicating, but it's always good to put a
Yeah,
face.
yeah, the face-on-face meeting is much more better. Thank you for accepting our um I forgot the word.
Invite, invite
Oh yeah.
for the podcast.
Thanks.
Yeah,
Yes. Yeah, unfortunately, today Dan is overloaded with his work, so he said that he cannot attend for today. We are just boss. Is it comfortable for you?
yeah, that's fine. Yeah,
All right, perfect. I'm doing the recording of the podcast so I can put it laterly on the YouTube and share it in different my social media platforms. Is it okay for you?
yeah, that's fine.
All
So
right,
I
perfect.
assume
Then
a lot of your audience isn't English speaking. So do you put subtitles in, or how do you end up kind
no,
of adjust?
there is no matter. We're doing it just for fun. We're doing to informative. We're doing to the global community. So
Oh, okay,
it's not just only for my network. It's for the global watchers. It's for the global enlightenment, making safe the world much more better. And I hope my network and your network, hopefully, will gather so much from our meeting today.
you bet. Yeah, I've done a few of these, so always good to come on with a different person and I appreciated the questions that you sent. So it created some deep thinking on my part for a couple. So hopefully, you find it enlightening and helpful to your community.
Thank you so much. Can we start? Perfect. Now, with the first question, with over 40 years in nuclear operations from the US nuclear program, that's so exciting, and later consulting, what was the biggest personal danger or closest call you ever faced, if it's not classified, of course?
You bet. So I had a couple. Both of them were near-death experiences, but I'll just share one of them due to time constraints. Uh, we were bringing in a very large multi-ton cask that had nuclear fuel in it, and you had to go into a truck lock and open up a very large um, overhead roll-up door, motor operated. And we just the cask inside, the door operating normally. There wasn't any abnormal sounds or anything, and I needed to close the door. So I'm standing at the threshold of the door, and I pushed the button for the down, and the door didn't move, didn't make any sound. And I thought, well, maybe the contact's just dirty. So
Mm.
I pushed it again, nothing. So then I pushed the up button, nothing. Pushed the down button, and one side let go, and half that door comes swinging by and missed me by inches, made my hair move. Had
Oh,
I been standing in the threshold, it literally would have killed me. It,
oh my
it,
God.
it was a very, very heavy door, very large. And for me, that was kind of a pivotal moment in understanding risk and danger, and even the term near miss, because that's about as close to a near miss as you could get. And in the terminology in the world that I come from, we would call this a hidden critical step. We, I didn't recognize the risk. I didn't recognize the stored energy because, I raised something up and we had potential
Yeah,
energy stored.
yeah,
And
right.
yeah, and a malfunction unknown to me was about to occur and put the wheels in motion with the potential. If I had not been killed, somebody else could have, because there were three of us
Yeah,
standing there and just waiting for the door to come down. And those doors pose a lot more danger than people recognize. The
right,
potential
right.
for failure is there. So, anyways, I just found that to be kind of this real unique moment in my career to recognize,
The
risk in a different way.
Yeah, yes, yes, totally true. And that's the example. Even the profis can get harmed by accidents. No one is, uh, how can we say, get insured from the dangers. It's they are literally everywhere. If you are the profi, if you are very attentive to the details, something can happen. However, whatever we do. That was really interesting. Yeah.
Yeah. And we might even classify that as routine work because it's something we did on a regular basis. And we never talked about the risk of that door. Now,
Ah,
later on, fast forward, I was working up in Canada at a very large nuclear facility doing what I do now, consulting. And they were adamant about providing in the pre-work discussion that
yes.
the dangers of those roll-up doors, because they move very large casks with nuclear fuel, spent nuclear fuel, and they said, we don't walk through those doors, we walk through the man door. Even though that big, huge door opening is there, they said, we always walk through the man door, not the roll-up door, even
But
if it's open. And it was
yeah,
because they had recognized the danger and they had identified it. But in my previous service as a technician, I
yep.
didn't, we never had that discussion. So it was nice to see the evolution and understanding of the potential for that hazard, even though at the time we didn't recognize it or discuss it.
Yeah, that's right.
It's just
If we don't see it, there is no meaning that it's not exists. That not mean it not exists if we don't see this. If we don't thought about something, that doesn't mean this danger isn't exist at all. Yeah, that's right. So you co-authored the book Critical Steps. What made you decide to write this book?
so. I'll give you a quick history. So I was working
Yep.
with my mentor Tony Machera, who kind of the father of human organizational performance, or what used to be called just human performance, at the Institute of Nuclear Power Operations, post 3 Mile Island. So this guy, he worked with some of the great minds in psychology and understanding safety, and put together, based on his Navy nuclear experience, similar to mine, a set of basic principles uh, and guiding practices that we used in the military, but he formalized it, gave it the names, and one of the terms that came to light is this term called critical steps, and this came
Yeah.
from nuclear weapons handling, and it
Ah.
evolved. And
Ah.
obviously, with nuclear weapons, you would have a critical step, a moment in time.
Yes. Yes.
Uh,
Yes.
so Tony and I were working at an oil refinery together, uh, teaching this subject, and we were driving back to the hotel, and he said to me, how would you like to write my next book? He had written a book called Risk-Based Thinking.
Ah.
And what a great honor. Here's the guy that really brought this to light to the world. I mean, it's being used in every nuclear power plant in the world, not just the United States, North
Yes.
America. Every nuclear power plant in the world uses human organization performance or human performance.
Yeah. Right.
And I said, yeah, there, no greater honor, Tony, is to write this book with you, because he had written a chapter in this risk-based thinking book, and this
Hmm.
book's probably 11, 12 years old now. And it was my favorite chapter. I wrote notes all over the margins, as you can imagine. And I had been speaking about it at this training session. I gave that, and he loved what I was talking about and my approach. And he
Yeah.
and we saw this big gap, um, in the industry, that people tend to focus on compliance metrics and eliminating human error. And that's the kind of the safety focus of today. And what we found is that, um, not all work is equal, not all actions are equal, and not all
Unfortunately.
human error is equal. So there's, if I make an error right now while we're talking with them, I'm very highly likely to do, and you will too. It's not consequential. Yeah, it might be a little embarrassing. We might laugh. There's no harm done. There's no damage. But in the real world, there's times when errors matter and there's times when errors don't. And when they do matter, we have to slow down, take deliberate actions to
Right.
mitigate for that human error, or to identify it if it's been made and there's no potential harm at that moment, but it could be future harm. So that was kind of the idea, is that, we would go and put this into the words. And we worked with another colleague who has a very similar background to mine, Navy nuclear safety, working in the Department of Energy, Navy nuclear, commercial nuclear power plants. and his name is Jim Moranis. And we wrote this book, and we really wanted to provide uh, the practitioners, the people that have to implement, the safety professionals, the operations staff, supervisors, not just the theory, but more importantly, the practical approach. So every chapter in the book ended with things you could do tomorrow. Because if we're not giving people, I mean, I got a bookshelf full of books and drawers full of books
Yes,
that I've read, and I'm
I
sure
see.
you
Yeah.
do too. And they're great books, but so many of them leaving you with the need to understand, well, how do I apply this theory? How do I apply these concepts? And
Yes,
so we
right,
said,
right.
you know what? Let's lean on our experiences, broad experience between the three of us, bring to the world these concepts. So our book has been selling literally in every continent in the world. We need to convert it to different languages. I think that's one of the big things we could do is to help the community with that. But um, so what we recognize is that work is complex, and the challenge of complex work is then how do you classify those actions into
Hmm.
a way that's simple to understand for the frontline worker, not for the theorist, not for the safety provider.
Yes. For
How do we make
everybody.
it tangible? Right?
Yes, to make it understandable, make it applicable, so you will not leave your reader with the question what to do next. That's
Yes.
genius. I think that's great.
Yeah, exactly. And so we started every chapter with a story, like you just asked me what, and I wrote a lot of those stories. Tony asked me to write the
I
stories
like
to,
stories.
yeah, me too. The power of stories is powerful. And so we put a story in place and then we went back to that story as an example. So what we were trying to do is help people understand what is a critical step. What is
Yeah,
that moment in time
right.
when if we've made an error at that step or a previous risk important action, we will have a loss of control. What do I mean by that? That loss of control is the loss of control of the hazards, energy, movement of mass, or transmission of data or information. Depends on the type of work you're doing. So if we lose control of it immediately, in other words, I can't bring it back. Let me give you an example. If I open a valve and I'm at a refinery and I introduce a product into the product line and it's the wrong product at the wrong rate or the wrong mixture, and it goes into the reaction vessel, I could shut the valve, but I've lost control. That's still going to happen. There may be a delay between the action and the result.
Yeah,
The loss of control is immediate. We've lost that control.
yes.
And then that results in intolerable and irreversible harm. In other words, I can shut the valve, but I can't take back the harm. It's still going to happen. And intolerable meant that it was beyond a threshold that the organization is willing to accept. It could be a loss of life. It could be a monetary value for a loss
Yep.
of losing
Yes,
a
right,
tool,
right.
piece of equipment, or a system. So that's kind of how we did it. And what we also recognize and I'm sure you've seen this in your discussions with other folks. I love to bring this up. If everything's high risk, everything's important in that job, then it's equally unimportant because
Hmm.
we haven't classified those actions in a way that says
Yeah,
let's 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 differentiate the
to
action
have an
because like I said,
understanding. Yeah,
yeah, and we got to create clarity around that that's simple to understand that folks can put into action. And then with that, once we understand that classification, and I'll just give it to you real simple and we'll discuss it more. Those are risk important actions, the risk important conditions they create, and then the critical steps. It's just basically those three. And everything falls into those categories
uh,
that matter related to risk. Now, once we've done that, then we can say, how do we prevent human error in those different parts? Because it's not just enough to say we've got to prevent all human error because that's not true.
yeah,
Some things we can make an error, but it's reversible up until the point of the critical step, that point of no return, if you would. So
yes,
we
yes.
can't we can't treat everything equally, or we end up in a space where nothing becomes important because it just becomes noise. Like if you go to a pre-work discussion and they say
Hmm.
this is high risk work, everything's important. Well, no, it's not. It's not
Yeah.
equally important. So we need to
Yes.
give them a way to do that.
Yes, that's right. Remembering and talking about the classifying and about the losing the risks. I remember when I was a kid, used to watch the cartoon named the Superman. If you know, it's
I do.
yeah, of course you know. Sorry, a bit nervous about it. The Superman. Watching the cartoon about him, and I'm totally remember even the Superman uh, putting things back after something happened. The control is lost. He cannot put things back in the order. He cannot come back, give back to life a dead person. He cannot build some building which is destroyed after some disaster. He was coming and dealing with the consequences. He was dealing with the things that happened after what happened, after people made this one critical step, and after this the crisis starts. Even he cannot go back in the time to stop once this critical step which is starts the problem. So yeah, that's right. I just remembered the moment from my childhood, and I thought that they're related. Even Superman cannot do anything. So how we are people, we should directly and very attentively classify the problems, classify the dangers, watch at the workplaces. And by the way, we are talking about these steps. Can you say, please, how does it differ from a normal task or high risk task?
So, if we're calling something high risk, it's usually because there's some sorts of energy or we're moving mass in the industrial environment. So we'll stick to those two concepts. So if we're changing the state of a system, in other words, you're going from this state to a different state, we're transferring energy in some way or we're moving mass through a system. So we know that point, that touch point, when we touch the system, we either push a button, flip a switch, or open a valve, it changes the state of the system. Now, there was likely hundreds, if not thousands, of actions that occurred to set up that point, that what we call a point of no return. This is where you have an immediacy. There's no second chance. If
Yes,
I got it wrong, bad things are going to happen. And all accidents are a result of a failed critical step.
yes,
So, and there's either an active error at the critical step or a latent error that occurred at what we call a risk important action. Now, let me ferret out the risk important action for you. So, let me give you an example. If I'm taking
yes,
off in an
yes, please.
airplane,
Mhm.
a pilot gets into the plane and thousands of maintenance activities have occurred. Thousands. If they were done incorrectly and not caught and corrected, we've got a landmine sitting there. But let's say the pilot's not going to go check those thousands of things. He or she is going to take the controls and validate safe conditions. Those are what we call risk important conditions.
Uh-huh.
All those actions that were being done were risk important actions. They brought safety or danger as
Yes,
just a normal part of work. Sometimes, like removing a component brings danger, putting back a replacement puts safety back in the system. And all actions bring safety or danger. It's just a
yeah,
natural part of doing work. Now, the
yes,
danger only comes into play if I don't do it correctly and I don't correct that error, what we call a latent error. Most events, in 80 to 90% of the time, are accidents or result of those latent errors that we didn't catch. So we have to put in place verification methods, validate safe conditions. These are the risk important conditions. So what the pilot does is a pre-flight checklist.
yeah,
Is it absolute safety that that plane's not going to crash or not take off safely or the engine's not going to
right.
start up? No guarantees. But it does give us some confidence in the system from what we know that it's ready to go. So
Yes,
it's a subset, right? It's a pre-flight checklist. And as someone who flies a lot, I'm hoping they did that and did it well. And so the
yes,
critical step in this case would be starting the engine. That's one. And two, taking off. because once you take off or you start that engine, both of those are continuous critical steps because there's
Yes.
a constant state of energy change. It's not a finite point that stops. It's just a finite point that starts, but it's an infinite transfer of energy up into the
Yes.
point we land and turn those engines off. So we once we start to understand that and we classify work in the workplace, no matter what the work environment is, we start to then understand, okay, what error prevention tools or mitigation strategies do I need to put in place in those three different phases, right? Risk and port
Yes.
actions, validating the conditions, and then the critical steps. So
Yes.
that's kind of the gist of it. You got some
Yeah.
questions on that? I gave you a lot of
Oh,
information.
yes, we have too much questions for today. I just remembered one anecdote, one funny story about you talked about the pilots who are switching airplane. So there's a hall inside the university. The professor is talking about the moon expeditions from the Louis Armstrong, and he says the Armstrong was a hero. So one student raises his hand and asks, why Armstrong should be a hero? Just fly to the moon. What's the important thing here? He says, listen to me. Imagine a five-floor building, very high building at 10 floors, doesn't matter. And imagine that this building is fulfilled with the fuel, and the Armstrong sits on this building, and one person from another place tells him, Armstrong, you're totally safe. We have calculated everything. Your pilots are these guys who are sitting inside this barrel of full of fuel, not only themselves, but also with the um, I forget the word again. The people who must fly to another country. And imagine that if these all steps are not provided correctly, it's almost accumulated too much dangers that airplane can blow up even in the place. Like one point, one push of one button and blow up if the step is not taken correctly. Yeah, so that's right. And that's why also pilots and also the Armstrong is hero because he's sitting at the full of fuel barrel like 100 meters, I don't know. And they're saying you're totally safe. We are calculating everything. There is no guarantee, absolutely no guarantee that he will fly to the moon. Even in the 60s, that was the 60s. We saw how things can go badly, even from the calculated systems. Something will happen bad. So yes, I'm totally understanding you. And the question, maybe this question was for Dan, but I want to ask it for you if you don't mind. Many safety professionals still treat human error as something to be punished or trained away. What do you think? How leaders can move from a blame culture to learning culture when it comes to HOP, HOP? Is it HOP or HOP?
Yeah. It hop or HOP. It doesn't really matter which.
Uh-huh.
A lot of people abbreviate it just saying the word HOP as hop because it's a English term. But
Yes.
I prefer to call it HOP because, or H and OP, human
Hmm.
and organization performance.
Yeah.
Um, so in the past, Dr. Sidney Decker talked about this in his book, and I highly recommend this book as a starter primer on human error. Is Field Guide to Understanding Human Error by Sidney Decker. Fantastic book.
Yeah.
Now, what what he gets into is that in the past, many cultures, many organizations, when I say culture, I meant the organizational culture,
Yes,
they
I
have
understood.
a culture of blame, right? And it's the bad
It's so
apple
bad.
theory.
Yeah.
So I've got a basket of apples, which are the workers. And when one of them messes up, if I take that bad apple out, the rest of the basket will be good. Well, we know that's not true because we in the past, I always like to think about it this way. When my only tool is a hammer, I'm looking for nails to hit. And that's what many
Yes.
organizations do, right? They look
Nice.
for
Very good. I should write it so somewhere.
so um what Sidney says in his book is we need to take an inside the tunnel view. In other words, if you take the view of the worker, the person that was doing the work, and you step back instead of saying they should have, they could have, those are what we call counterfactuals, things they didn't do. And you said, what did they do? And why did that make sense under those conditions? We start to understand and reframe human error differently. Because I think in the past, what we said is we found the problem, it's human error. This person did it, therefore get the hammer and we'll hit them on the head. And they either punish the person or remove them from the organization, fire them. Well, I think more importantly, we need to rethink that. We have to rethink the way we look at incident investigation. Human error is the
Yes.
starting point, not the end point. And the understanding and what I teach is that understanding human error is very, very important because it gives us a starting point as an incident investigator or accident investigator to say, okay, I know what the error was. Now let's pull the
Yes.
string and understand what were the drivers. Why did the organization set this person up to fail? Not why did they fail? Why did we set them up to fail? That's a different
Yeah.
question. And so when we come about it that way and we frame it that way, then we start looking at the organizational factors, the systems that set them up, whether it's bad procedures,
Ah,
bad
that's why
direction.
human and organization.
Yes, because we need to understand the human element as well as the organization. In fact, the organization one to me is more important. So, anyways, that's kind of the advice. But we can't learn just from those incidents. We need to look at were there unclear procedures? Were there conflicting goals? Were there some resource constraints that shaped that behavior that day?
Yeah.
That's what's important because we're not going to prevent the event from re-happening by firing the person. We're going to prevent recurrence by understanding the system factors, what I call the organizational factors that were drivers for this incident. So just to kind of add to this now, understanding human error and treating our incidents difference, there's one other thing we also need to do. We need to create a safe environment for people to speak
Yes.
up, right? So if we want to be a learning culture, which is the beginning of a just culture or a safety culture, in order to have a just culture, you have to have a learning culture. You have to create that environment where when someone speaks up and says, I made a mistake, we
Yes.
don't punish that mistake. We had actually raised this person up and say, look, this is exactly what we wanted that person to do. We appreciate it. We broadcast it to the organization. This person spoke up that because they self-reported. So
Yeah.
that's the idea. And so a lot of organizations like the airline industry has a safe reporting anonymous system that you can report to, say, I made a
Hmm.
mistake. I found a mistake or I made that mistake.
Uh-huh.
So there's a couple different ways to do it, but it's called an honest mistake policy. I made an honest mistake. It wasn't a deliberate act. Like nobody comes to work to make errors. Like it's
Yes.
not our that's malicious component is so seldom that I don't even like to talk about it because it really doesn't
Hmm.
happen very. I've done hundreds of incident investigations, and I would tell you, with the exception of one, well, actually there were two, that we were in the non-compliant space. The others were all what I would call honest mistakes. So it's in the
Yes.
neighborhood of like 1% of the time people are deliberately trying to be non-compliant.
Um, at that moment, as a sorry, okay. At that moment, as a man who worked with so much people around, I maybe trained for 4,000 person face to face. And at that exactly that point, I have a question from myself. And if organization is not punishing, but going to rule and going to help to their employees, that's good. And what to do with this type of employees? if they think they have a mindset like that, if I'm doing mistakes, if I'm doing what I want, the organization will not punish me, everything okay, I can leave, I can work as my heart tells me, and they are going to, uh, how can I say, um, they don't want to take responsibilities, acting irresponsibly, don't doing their job properly, and how to deal with this type of employees, which are toxic, which are don't want to work and don't want to act like organization and don't want to act on proper behavior at their workplace.
Well, for me, and I get asked this a lot of times when I go out and teach this to large organizations because um, there's still a thing called accountability, right? And
Mhm.
so if we frame it for the organization that these are our standards and expectation, and there's a deliberate act not to follow those, that person is a cancer for your organization. They got to go. You
Oh,
got to fire them.
right.
And I'm not in a belief of a blame-free environment, but a
Uh-huh.
learning environment. Those are in conflict with each other because blame-free says you get out of jail free card no matter what, and that's not the case. There's still accountability. So if we set the standard, we have a set of expectations, and the person deliberately, not accidentally, deliberately takes an action to circumvent that system for expediency, ease of work, whatever reason, and a bad thing happens, or even if it doesn't happen and we catch them, we need to hold them to account. I was at a
Yes.
refinery where the manager asked me this. A gentleman had gone in to change a light bulb in a system that had a higher level of voltage. It was a large system. And he said the guy got up there on a ladder and didn't use the lockout tagout system
Uh-huh.
to render the system safe. And someone came by and he's laying on the floor and they said, "What happened?" He said, "Well, I got a shock up there." And he said, "Well, just stay here. I'm going to get help." He comes back and the guy's back on the ladder working. And when they
Wow.
did the investigation, they determined that this guy had not did the the procedure to open the breaker to work on the system.
Oh,
And that
that's
that
not good.
manager said to me that refinery manager said to me, he said, "So what would you do?" I said, "I'd fire him." He's, he said, "Okay." And then him and I were on a good wavelength because he thought I was coming in with this idea that we're in a blame free environment. He just made a mistake. No, the guy didn't make a mistake. That's not human error. That's a deliberate circumvention of the systems and
Yes.
process. You still got to hold them to account.
Mm-hmm. Yes, that's right. And in the future, they even can cause the human death, employee death. That's horrible too. It's good to fire
Oh
rather
yeah,
than to
there's
keep.
times you gotta let them go. Absolutely.
Yes, and rather than to keep and open the way to some deaths, that's horrible. Yes, that's a good step. Not the critical, but the good step. Uh, Even the critical step for the organization, I can say. So the final challenge. Now, if you could change just one thing in how in safety profession approach human performance and high risk operations tomorrow, what it be and why?
Well, I got pretty simple advice here. First
Yes.
off, um, stop paying attention to what's easy. So what's easy is the bureaucracy most safety organizations created. So they create metrics or KPIs. They create safety dashboards. They create a lot of observations and they measure safety by the number of observations being done. And quite often I'll come up to a facility and outside the facility, they'll give a number of days without a lost time work accident.
Yeah.
And that always scares me because that tells me that organization is hiding the truth.
Mhm.
They don't have a reporting culture. And what's some interesting statistics here is that organizations that have a high level reporting of low level incidents, and I mean, they investigate everything like the nuclear power industry does, they have a low death rate. But
Yes.
organizations that have these high safety statistics kill people. An example is BP oil out in the Gulf near
Uh-huh.
the United States, where Deepwater Horizon that day they were receiving a safety award, and then they blew up the place and killed a dozen people. That's a
Uh-huh.
prime example. That
Yes,
safety
yes.
record is not indicative of understanding risk. So what I would suggest it's very simple.
Yes.
Start where work is, look at the work and understand where real risk resides. That point where the workers are changing the state of the system. And by understanding that, um, and quit looking at the paperwork. I think we create uh, paper tigers with the paperwork systems that safety systems drive. And you can plaster the walls of my office with all the safety system that we put into place that are nothing more than a paper tiger. They will not
Yes.
protect. We have to understand where real risk resides, and that's so. Let's say I'm a supervisor or I'm a safety professional. I
Uh-huh.
have limited time to be in the field.
Yeah, that's
Limited
right.
time. So where should I spend my time? Well, if you know that point of inflection, that critical step moment, what you say to the workers is when you get to this point, I want a hold point. I don't want you to take that step. I want you to call me and then validate the risk and port conditions have brought safety, that pre-flight checklist. You show me that you're ready to take that. And that saves you time. You don't need to be there for hours and hours of watching work. You need
Yes,
to be
that's
there
right.
when it's most important.
Mm-hmm.
And you get to start to understand, are they managing risk? Do they understand that? And one other place is in the pre-work discussions, whether you call it a pre-job briefing, a huddle, toolbox talk, I don't care what you call it. Pre-work discussion, the workers need to be able to tell you, and you don't tell them. You need to understand what they know before they go do work. So you understand, do they know what the risk important conditions are and the critical steps? If they know and they tell you how they're going to mitigate for human error, you're ready to go. Now you're starting to manage risk. And what I hear at a lot of those pre-work discussions is a whole bunch of minutia. I mean, stuff that just doesn't matter. We need to be talking about risk when we get to the
Yes.
pre-job
What's
briefing.
important?
What's most important? That's right.
Yes.
And
Right.
where can we control the risk? And it has to be at that point where it's the most, that critical step. So I think if we start changing that, not only do we uh, start to manage risk better, but we shift it from paperwork process to the
Yes.
point of risk at where the workers touch the system. I think that's the most critical thing. Then we can, I'd rather have a handful of safety observations being done or work observations being done than thousands of them that mean nothing that just tell you somebody wasn't wearing their PPE or protective equipment because that's what most of them say. And
No, not
that
at all. Not at all.
there's no value in that. There's
Yes,
no
right.
value because it's not actionable. But if I do an observation that starts to look at and manage risk, did these workers manage risk at that moment in time properly, or were they challenged in some way? The challenge or the proper performance, either one are learning points. We need to learn
Yes.
from that normal work,
Right.
not just after an accident has happened.
Unfortunately, we have less than 1 minute. It's a Zoom shows
Okay.
me that we have only left less than 1 minute, so I don't even saw our seconds here. So it's time to finish. It was so interesting, but unfortunately, time is going to um, over. Thank you for so much for attendance. I'm totally happy to host you today.